Well, good morning, Group D. This is Mr. Lopez again, wishing everyone a happy Friday. You have made it to the end of the week. I am very proud of the work everyone has been doing. I have been receiving several emails and work that's been submitted via RenWeb from your parents, showing me the excellent work everyone's been doing. I want to say a good shout out to Mr. Lowe. Good morning, Isa. Good morning, Zahna. Ayan, good morning. Raman, good morning. Jabril, how are you? Lena, how are you? Wave, hello. Hello, Miriam. Going down the list, making a mental note where everyone sits, and I hope I caught everyone. I think I did. If I missed your name, I do apologize. I'll try to make a better effort as soon as I'm done today. So let's go ahead and look at 16.4, and we're going to be relating figures, fractions, and area. So we want to make sure that we're focusing on the area and relating those figures, fractions, and area. Now, the first assignment here, or the first question that says investigate, requires you to have a pattern block of a hexagon. Of course, we're not in class. We don't have the hexagon patterns available to pass out to you. I do have a copy of a PDF file on RenWeb that you can download, and it has a picture of a hexagon, and it looks like this. So make sure you have that one right now. If you don't have it, pause the video, go to RenWeb, go to the document section, and you will see this page there for you to print out. Okay, once you have it, let's go through the steps here and let's answer the questions. And again, take your time. And the key here is not to get overwhelmed, because when we start dealing with more of these analytical questions, it really requires us to just focus and look at what they're telling us and observe and identify what's visible, what we can observe, and then make a logical determination of the correct answer. Okay, so let's do this slowly. So you should have the pattern already in front of you, a colored pencil, a ruler if you have. If you don't happen to have your ruler, just use a straight edge. And let's perform the operations here together. Say so connect. Use what you know about combining and separating pattern blocks to explore the relationship between fractions and area. That's what we're going to be focusing on. Relationship between fractions and area. So we already have the hexagon. So let's do the first thing. Divide your hexagon into two equal parts with equal area. What new figures have you drawn? So if you take your, and I don't have a ruler here on this app here, but I'll do my best to draw straight lines here. And I'm still using my mouse, so forgive me. That pen has not arrived. I don't know what's going on. I guess with the things happening right now, everything has been back ordered. So hopefully I'll be able to have that pen here, and it'll help me a lot. So again, I'm using the mouse. So it says to divide it into two equal areas. So I just go right down the middle, and we did this one in class. And now we have a new shape. It's right here. What do we call that shape? Write it down here. It's a trapezoid, yes, or a pentagon. Either one is correct. Trapezoid or a pentagon. We have two, right? Two halves. Write the fraction that names each part of the whole. And again, this is the whole, and these are parts of the whole. So what we do when we see that, the whole, so how many do we have? 1, 2. Okay. And the name of each part, the name of this part, the name of this part, well, this one's 1 out of the 2 that we have, because the 2 make the whole. So to name A, say we call this one A and this one B, the name of A is 1/2. The fraction for B is also 1/2. So this is one part, this one, out of the whole, which are the 2 parts. That's what you have to figure out, and that's what you have to determine right now and understand before you move on. So write the fraction that names each part of the whole you divide it, 1/2. Each part is half of the whole figure's area. Each one of this is half of the total area. write the fraction that names the whole area. Now, now when I'm looking at the whole, how many do I have? Well, I know I start off with 2. And how many halves do I have? Well, I have 1, 2. So whenever you have the numerator and the denominator the same, that equals 1 whole. No matter what the number is, it'll equal 1 whole. Okay? So 2. That is what you should have right here. Does everyone understand this? Yes? Thumbs up, Lena. We're good. Miriam? Zahina, we're good. Mr. Lowe? Ayan, how are you? Good. Ramen? So I'm going down my list. Who am I missing? Lena, Miriam. I want to go down the list. I see Ramen. Then I see Miriam. I see Ayan. I see Jabril. I see Zahina next to Jabril. I go down. I see Isa, Mr. Lowe, Lena in the middle. And did I say Jabril? Well, hello. Raise your hand. Good. Oh. My mouse doesn't seem to be working. Alright, let me clean this up. If you have questions again, go back and replay the video and understand what is being discussed here. It's very important that you understand the whole, the halves, and the area. Okay. We're going to do this together. The rectangle at the right is divided into 4 parts with equal area. So here are the 4 parts. Okay. And the area is equal. So if you want to pause the video and attempt to answer these questions and then check to see how you did, that's fine. If not, just follow along with me. So if you want to pause it now. Okay, welcome back. So write the unit fraction that names each part of the divided whole. Each part. This one, this one, this one, this one. The unit fraction that names each part. So again, going back to what we know, well, how many total parts do I have? I have 1, 2, 3, 4. The name, and then the name for each one of these, well, that's 1. 1 out of 4. Each one of these is considered 1 out of 4. What is the area of each part? Now we go back to area. How do I figure area? Well, I can't do length times width. What's the easiest way? I count the squares. 1, 2, 3, 4, 5. The area is 5 of each part. How do I know that? I just counted them. Remember, the area, it has to be divided into equal parts. And we already know they are because we already answered this one here. And if you count them, all of them have the area of 5. How many equal shares does it take to make 1 whole? How many equal shares, how many of these do I need to make 1 whole? Well, I count them. 1, 2, 3, 4. I need 4 equal shares. They have to be 4. Remember, because 4 equals 1 whole. Does each equal share of the whole have the same shape? So do each one of these have the same shape as the other one? Well, all I have to do is look at them. Are these the same shape? No. No, it's not. They're not the same shape. They have the same area. They have the same fraction name, but they don't have the same shape. Is the area of each equal share the same? Explain. How do you know that? How do you know the area is the same? What did we do to get this part here? Yes, count the squares. Count the unit squares. And if I count them, they'll be 5. Simple, right? Yes? Excellent. Good job. Let's move on to the next question. Okay, this you'll be using your ruler here or a sharp edge. Divide the trapezoid into 3 parts with equal area. This is the key right here. 3 parts, they have to be equal area. So make sure you use a pencil here in case you have to erase. Okay. Write the names of the new shapes. Then write the fraction that names the area of each part of the whole. If you have to pause the video, work it out, and then come back. Okay, welcome back. So I'm going to divide it into 3 equal parts. So I'm going to do that first. I have to visualize this. So, okay, how can I divide this? I can't go this way because then I won't have equal parts. I'm going to have to start seeing it. And if you do this, go down here, then go down here. Now I have 3 equal area parts. 1, 2, 3. And that answers this one. That satisfies that. What is the name of this shape? It's a triangle, right? What is the fraction name of the area of each part? What is the fraction name of the area of each part? The fraction name. So how many total parts do I have? 3. The fraction name of this one is 1/3. 1/3. So make sure you understand the terminology. The fraction name that names the area of each part of the whole. Okay? You have to listen and read it carefully. That's why reading is very important. Let's move on. You good? Yes? And then let's just do what it tells us to do. Draw lines to divide the figure into equal parts. That shows the fraction given. Here's the fraction. So, how many total parts, equal parts am I going to have? Well, the denominator tells me that. 6. I need to have 6. This one I need to have 2, and this one I need to have 8. So when I divide this into equal parts, I have to have 6 equal parts. So first thing I do, I'm going to go divide it like that. Then I go vertice to vertice, divide it like that. Then I go here and here. And then I want to check, do I have 6? 1, 2, 3, 4, 5, 6. Does that satisfy that? Sure it does. This one, I need to have 2 equal parts. So here's a rhombus. Okay. You can go this way, or the easiest way, this is the way I always do it. Go that way. And I have 2 equal parts. 2 equal parts. And each one of these is called 1/2. Okay. This one's called 1/2, and this one's called 1/2. This is 1/6. This one right here is 1/6. So how many total equal parts do I need? I need 8. So if you remember doing this in class, when we fold the papers in half to get 8 equal squares when we did our, what was it? The President's PowerPoint rough draft or the blueprint. This is the way exactly that we folded them exactly like that. How many total equal parts do I need? I need 8. I have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now again, please keep in mind I'm doing this with the mouse here. They're not going to be perfectly in line, but you get the idea. They have to be 8. Okay, very good. Okay, you can always pause the video before I explain the questions and then come back and see how you did and then make any corrections necessary. So let's do the next section. Draw lines to divide the figure into parts with equal area. So it has to have an equal area. Write the area of each part as a unit fraction. Okay, so first we need to divide it into equal parts with an equal area and then the unit fraction. So this one has 3 equal parts. So out of this shape, I have to have 3 equal parts. It's not saying that the shapes have to be congruent, just that the area has to be the same. So I know I'm going to need 3 parts. I have to figure out how many unit squares will be in each shape that I make in order to have 3 equal parts. And how do I figure that out? Well, you have to get the area first. So what is the area? 1, 2, and I'm counting the squares. 3, 4, 5, 6, 7, 8, 9. My total area is 9. And how many equal parts do I need? I need 3. And that equals 3. So each shape that I make has to have 3 unit squares. Then I just get my marker. There's one shape that has 3. 1, 2, 3. And once I do that, there they are. There's 1, 2, 3. Each one has 3 unit squares. That's equal. What is the name of this? What's the name of this unit fraction? Yes, 1/3. Okay, this one is 1 out of the 3. Okay, let's look at the next one. I have 6 equal parts. What did I do here? I have to get the area first. This one I could do length times width. 1, 2, 3 is my length. What is my width? 1, 2, 3, 4, 5, 6, 7, 8. And my area is what? 24. So I need to figure out how many unit squares are going to be in the 6 equal parts. This is the key, equal. So I divide 24 divided by 6, and that's going to give me 4. So each unit square that I make has to have, each fraction that I make, each shape that I make has to have 4. And then I just go and make my fractions that have 4. My shapes. There's 4, 1, 2, 3, 4. And they will vary. So long as that each shape that you make has, there's 4, 1, 2, 3, 4. Oops. 1, 2, 3, 4. And did I do that right? 1, 2, 3, 4. And here's the shape. Here's one shape. 1. There's another 2, 3, 4, 5, 6. And each one has 4. And what's the name of each one of these parts? What's the fraction name? Well, how many total parts do I have? I have 6. What's the name of this one here? Yes, 1 out of 6. Does everyone understand how I did my shapes? And notice, if I count the area in each one, they all equal 4. The area is the same. These have to be equal parts. This one has 4 equal parts. So let me get the area first. 1, 2, 3, 4, 5, 6, 7, 8. I have 8. My area is 8. I need 4 equal parts. How many unit squares will each shape that I make have? Yes, I have to have 2. So 1, 2. Here's 1. 1, 2. Here's another one. 1, 2. Here's another shape. Excuse me. And do I have 4? 1, 2, 3, 4. I sure do. What is my fraction? My unit fraction? Well, how many total ones do I have? And this one is 1 out of 4. Okay. If you have any questions, go back, review the video. Let's move on. So let's look at this. If the area of 3 rhombus equal to the area of 1 hexagon. So again, 1 rhombus equals what? And look, I'm looking at the area. To the area. Okay, the area of 3 rhombuses equals the area of 1, and I can't do the hexagon. I'm going to write the word hexagon. Okay, so it takes 3 rhombuses to equal the same area of 1 hexagon. Excuse me. Okay. The area of how many rhombus equals 4? Okay. The area of how many rhombus equals 4 hexagons? Well, what's the area of 4 hexagons? Okay, how many rhombuses do I need to equal the area of 4 hexagons? Well, I have to figure out how much the area is for this hexagon here. So I know I need 3 rhombus to make the area equal to 1. So I have 3 rhombus, and I know the area, it's equal to how many? To the area of 1, so 3. And what's it asking me for? The area of how many rhombus equals 4 hexagons. There's my other number right there. And your answer is 12. That's how I did. Does everyone see how I got that? Because 1 rhombus, the area of 1 rhombus equals 1. So now if I have 4 rhombus, 4 trapezoids, now I have 4 of them, what is the area going to be of how many rhombus? Well, then I have to figure this out here, right here. 12 divided by 4 is 3. 3 times 4 equals 12. Yes? Let's do the next one. Show how you can divide the hexagon into 4 shapes with equal area. Each part is blank of the whole 4 shapes with... Divide the hexagon into 4 shapes. So I'm going to go down here. I'm going to go down the middle. Okay. I'm sorry. They have to be equal. Oops, that's not it. Sorry. It's hard to draw it with this one. I drew it before. Where is it? Let me find it for you. So you go down the middle and then up one down like this. I had it right now. I don't want to show you the picture that already has the answers that I created because it's going to, we do this. It just looks weird when I do it with the marker, with this pen here. So here are my 4 shapes with the equal area, and each part, what's the name of this part? Yes, it's 1 out of the 4. And again, I'm just doing this right here, dividing it to the parts it's telling me to do. Excellent work. Alright, here we go to the next one. Divide the hexagon into 6 equal parts. So I'm going to do that again. Go down here. Then I go down here. Then I go down here. And I count 1, 2, 3, 4, 5, 6. Yes? Which pattern block represents 1/6 of the whole area? Which pattern block? What shape is this? Yes, triangle. Divide the trapezoid into 3 equal parts. So again, we did this one already. That one. That one. Which pattern block represents 1/3? Yes, it is the triangle here. Okay. I did this one for you already here before. Can't see it with my... where is it? I did it right here for you. So it's much, you can see that it's equal now. Okay. Triangle, triangle. Okay. Oh, I erased it. Let's do that again. Sorry about that. And we know it's a triangle here. Triangle. Triangle. And let's look at what it's asking me. So Alexis said that the area of 1/3 of the trapezoid is greater than the area of 1/6 of the hexagon. Because 1/3 is greater than 1/6. Does her statement make sense? Explain. So try to see if you can see this. And I'm going to be looking at this picture right here. Okay? Try not to show you what I typed out already for tomorrow. So Alexis set the area, and I'm looking at this one here. So Alexis set the area of 1/3 of the trapezoid. This one is greater than the area of 1/6 because what? And this is what she used, or Alexis. She 1/3 is greater than 1/6. Does that make sense? And the answer is no. It doesn't make sense. It doesn't make sense because Alexis is only looking at this. Is only looking at the fraction here. And if when you look at the fraction, this whole here, the 3, which is this one here, is not equal to the whole here, the 6, which is this one here. When you look at the fraction area, you're not looking at the figures, you're not looking at the triangles, you're looking at the fraction only. And when you look at the fraction only, it does not make sense. Okay, it's not true because you don't start off with equal parts here. Okay, you have 1/3. That's the 3 here at the bottom. You have 3 equal parts there, and here you have 6 equal parts. So you can't compare it with using this fraction here. Does that make sense? Because you're not looking at the area of the shape here. You're not looking at the shape. She's only looking at the fraction. And the fraction, you cannot compare them because they don't have the same equal whole. The whole's not equal because this is thirds, this is 6. I think that's what I typed out. Yes. Because they just looked at the fraction parts. 1/6, 1/3. All the triangle parts have the same area. Yes, they do. But since the wholes are not the same size, you cannot compare the fractions. The wholes are not the same size. And they're talking about the wholes, the 3, the thirds, and the 6. They're not the same. So those fractions you cannot compare those two at all. That's what I need for you to understand. Okay. You write a statement that makes sense. So what statement can you write that makes sense? And think about the area. Okay. The area of 1/3 of the hexagon is greater than the area of 1/3 of the trapezoid. Now you were saying, hey, but you said we couldn't compare it because the holes are not the same. Right now that we're talking about the area. We're not looking at the fraction. We're looking at the area of the shape. So if I divide this hexagon into thirds now, so now, oops, sorry. Now I divide this hexagon into thirds, so the holes are the same now. Get that out of the way. So now I'm going to make this one into thirds. Right now it's into 6. So now I get a new shape. So if I do, let's see, get a different color. So I'm going to divide it into thirds. Here's 1. Okay. There's another rhombus. Remember, and here's another rhombus. So I divide them. Let me draw that with different colors so you can see it. So here's one rhombus, and I'm dividing this hexagon into thirds. Okay. Change it. Here's another one. And here's the last one. See that? Now I have 3. Here's one rhombus. There's another one. 2. 2 is not easy to make. 2. 2 and 3. So now I need to, what's the name of this unit fraction? This unit part. Yes, it's 1/3. So now my holes are the same. My whole numbers here are the same. Now I can start comparing. So now I look at the area of this shape right here and compare it to the area of this shape here. And as I look at it, this is twice the area of this one. So I can say that the area of 1/3 of the trapezoid is greater than the area of 1/3 of the triangle. Now I can compare them because my holes are the same. I divided this one into thirds to equal the whole of this one into thirds. Okay, again, if you have questions, rewind the video. And if you still have any issues, just send me a text or an email. Okay. Okay, we did that part there. Okay, excuse me. I got so many windows open right now. Alright, we did that one. Oh, now we're into your daily task assessment and your homework. I hope you had fun with this, and go back and review the video if you have any questions. And again, take each section at a time and just outline what you know and logically work the steps. Please do not try to look at the entire word problem as a whole, because the first thing you're going to tell me is, I don't get it. Yes, you don't get it because you're not analyzing sections. Take small steps, write down, draw, color, write down what you know. Make it easy on yourselves. I hope this helped, and thank you for a wonderful week. Thank you for your cooperation, and I hope things are running smoother for you now. The next weeks that we have coming are going to be more intense, so stay focused, stay organized, and above all, stay sharp. I want to wish you a happy weekend, and we will see you again on Monday. For now, this is Mr. Lopez signing off. Have a wonderful weekend.